So this is number 37 from chapter 10. So calculate the number of molecules in a deep breath of air whose volume is 2.25 liters at a body temperature of 37 degrees Celsius and a pressure of 735 torr. So notice how I set this up. I organized my data right here. I had the variables set out, and then if they give me information about how it changes, I could do initial and final conditions here as well. But right now, all I know are these pieces right here. They want to know the number of molecules, and this would give me the number of moles, and then I could go from moles to molecules once I calculate the moles. So that's my problem solving process. Now I'm going to use the equation PV equals nRT. I'll solve for n right here, and then I'll be able to convert it to molecules. So divide both sides by RT, and then I have n is equal to PV divided by RT. My pressure is 735 torr. My volume is 2.25 liters. Now I want to use a R that's in torr, so that would be 62.4, and that's liters times torr per mole Kelvin. And then my temperature, I have to be real careful because my temperature is in degrees Celsius, and remember it's got to be in Kelvin. So make sure that you add 273 to that. When you add 273 to it, then you get 310 Kelvin. Because then my kelvins cancel with my kelvins, my liters with my liters, my torr with my torr, and I'm left with 1 over moles, which multiplied by the reciprocal, I end up with moles as my answer. So we're going to multiply those together, and then we're going to take that number and we're going to multiply it by 6.02 times 10 to the 23rd. So this answer right here is my number of moles. And then I put moles in a position where it's going to cancel, and for every 1 mole there are 6.022 times 10 to the 23rd molecules. And then I just did this all at once in my calculator, just took whatever this answer was and multiplied it by 6.02 times 10 to the 23rd, and I ended up with 5.15 times 10 to the 22nd molecules. So that's how many molecules of air are in one breath, approximately, one deep breath. And then letter B, it says the adult blue whale has a lung capacity of 5 times 10 to the 3rd liters, so that's a volume. Put your data down first to organize it. Calculate the mass of air. So now we're looking for mass, and they give us a molar mass right there, contained in an adult blue whale's lungs at 0 degrees Celsius. So our temperature is 0 degrees Celsius, which is 273 Kelvin. That's probably what you should do first. Always convert to Kelvin, because then you never forget. And then atmospheric pressure here is considered 1 atmosphere, 1 ATM, assuming the air behaves ideally. So the thing that we don't know is n, and of course if we find n in the number of moles, we could multiply the moles times the molar mass right here, and then we could get the mass in grams. And so once again, we're doing the same thing that we did right up here. We're solving for R, and so divide both sides by RT, and so then N is equal to PV divided by RT. My pressure is 1 atmosphere. My volume is 5.0 times 10 to the 3rd liters. My R is going to have to be in atmospheres now, so that's 0.08206 liters times atmospheres per mole times Kelvin. And then the temperature is 273. So then this number right here will give me my number of moles, and so then I'll take these number of moles right here. That's what my units are going to end up being after I cancel these right here. then I will put moles in a position where it's going to cancel. Grams is a new set of units, and if you carefully read the problem, see how it says there's 28.98 grams per mole. So that's where I get this relationship right here. And then I did this all in once in my calculator once again. And it turned out that there were 6,468 grams in one, inside the blue whale's lung capacity. And it just said the mass, so that's fine. If you wanted to convert it to kilograms, it's 6.468 kilograms of air inside of the blue whale's lungs.